Alright, so question number 2 says, what pressure would be required to compress 280 centimeter cube? So our parameters, let's take parameters. We already have our first volume there. Our first volume is 280 centimeter cube. So look at this. What pressure will be required? So the one that will be required will be the final pressure, right? When you say what pressure will be required, we're looking at final pressure, right? Gas at 660 millimeter mercury. So we have our first pressure for a P1 is given at what? 660 millimeter mercury, right? Let's continue. So it will be compressed from that to that. So we have our volume 2, second volume as 216 centimeter cube, and our pressure 2 as what? That's what we're looking for, the one we're looking for. And then I said our temperature remains what? Constant. That's K. Right. So looking at this, you know it's a Boyles law question. So our solution to this, we know that mathematically P1 V1 is equal to P2 V2. And since we are looking for P2, it means we need to divide both sides by V2, right? Divide by V2, divide by V2. So that from that, V2 will take off V2 here. Our P2 becomes what? P1 V1 over what? Over V2. So what our first pressure? First pressure is 660 millimeter mercury. 660 times what our V1? 280. All over what's our V2? 216. 216. Alright, so let's multiply 660 times 280. Give us 184,800. 184,800 over what? 216. By doing that, what do we have? Divide by 216. I will have 855.5. So we have 855.5 millimeter mercury. Right, so we have our P2 to be what? 855.5 millimeter mercury. So mathematically, you see it now. As the second volume reduced, the second pressure increased. Right, so that's how it works. Right, so we're taking some advanced questions. Let's take 2 advanced questions, 2 tough questions to see how Boyles law really works. I'll see you next video, guys. Okay, question 3 says a gas at a volume V0. So we are seeing the first volume. V1 is given as V0, right? In a container at pressure, right? At that, in a container at pressure P1. So we have our first pressure P1 to be P0, right? It's compressed to 1/5 of its volume. We are seeing the V2 as 1/5 of its of V1, and V1 is what? V0, 1/5 of its original volume. What will be the pressure if we're looking for pressure 2? P2 if temperature is constant, right? So that's the parameter. So we know that for Boyles law, P1 V1 is equal to P2 V2, right? We're looking for what? P2. So we divide both sides by what? By V2. That's what we said. This guy will take off this guy, so that our P2 becomes what? P1 V1 over what? Over V2. So this is over, that means to divide, right? So what do we have as our P1? P1 and V1 is P0 times V0 over what's V2? V2 is 1/5 of the original volume. Let me make it easier for you guys. This word over means to divide, right? So let's say this one divide by our V2. So instead of putting over, let's just make it easier by putting over what? 1/5 of what? V0. Very easy that way. Over means to divide. They're all the same thing. So just trying to arrange it. The answer there becomes P0 V0, right? Divide by 1 times V0. There is V0 over what? Over 5. You know from your mathematics, arithmetic, we know that this word divide, we change the divide to times, we invert, right? It becomes easier that way. So with that, it's going to be P naught V naught times what? Times 5 over what? V naught. Here should be over 1, right? That way, P naught we cancel, V naught we cancel V naught. We'll be left with what? P naught times 5. So that'll be what? 5P. That's our pressure 2. So P2 becomes 5P. So easy as it gets. It's still the same thing, right? You can still do it the normal way, but I'm just trying to make it much easier, right? Can you divide, because we know that P naught, PV is over what? 1 over 5V. So that becomes PV over what? V over 5. So how do you do this now? So students become confused with this, right? So that's why I just do it. I showed you guys the principle of 5 by 5 near by near. That'll be 5PV over V. V takes off V, P, 5P, same thing, but this is better to follow this way. Let's see how easy it gets, right? See you in the next video, guys. Thank you. Alright guys, so let's look at the question. It said the ratio of a given mass of gas from initial to final volume was given by 1 to 1.5. So initial pressure P1 is 1 and P2 is 1.5. Initial to final. Calculate the resulting volume if the original volume, so V1 is given as 600 cm cube. What then is V2? That's what they are saying. It's very simple, right? So we know that P1 V1 is equal to P2 V2. Since we are looking for V2, divide both sides by P2, right? P2 take off P2, V2 becomes P1 V1 over what? Over P2. So what's our P1 there? P1 is 1, right? And our V1 there is 600, right? And what's our P2? P2 there is 1.5, right? So 600, 1 times 600 divided by 1.5, what do we have? 600 divided by 1.5 gives us 400. We have 400 centimeter cube. Therefore, our volume 2 is 400 cm cube. Very simple. So guys, just go through it, see how you can get them done. You can leave your comments on the comment section, and please make sure you like, subscribe, and share the video to your friend. I'll see you in the next video, guys. Thank you.